In this lecture, we will discuss about universal shift register. Why it is calling as universal? If we take other registers, they are doing only single work. Suppose if we take this one, it is doing right shift, left shift, and parallel in, parallel out. That right shift and left shift comes under serial in, serial out. So it is doing serial in, serial out and parallel in, parallel out works, more works compared to other registers. That's why universal. Suppose in movies, if a actor playing more roles, he called as a universal star. Like this here, this register playing more works. So it's a universal register. So to construct this register, here I take an 4-bit register. So I need 4 D flip-flops and 4 4x1 multiplexers. The size of multiplexer is fixed. Suppose if I take 5-bit register, I need 5 D flip-flops and 5 4x1s. Still, the size of multiplexer is 4x1 only. Okay. So if we take 4x1 multiplexer, we need 2 selects, and it contains 4 data inputs and 1 data output. Okay. So here we can see I given negative clock to the all flip-flops, negative reset to the all flip-flops, and I given positive clock to the all flip-flops. This is the output of each flip-flop. This one, this one, this one. Okay, and this is the input of each flip-flop. Input. And this is the clear or reset. Clear or reset. And this is the clock edge. Clock edge, clock edge, clock edge. So at the output of all flip-flops, we are taking parallel output. And where we giving parallel input? At this place. We are giving parallel input to multiplexer. We are taking parallel output from D flip-flops. We are giving parallel input at this terminal. Observe that. Because there are 4 data inputs to multiplexer, we are giving at this point. When select is 1 1. Both selects are 1 1. Okay. And this is select 1 and this is select 0. Okay. See, these selects are connected commonly to all multiplexers. And where we giving serial input? Here we are giving serial input. We are giving serial input at this leftmost multiplexer. And that also to the select input when became S10 and S01. Okay. And where we taking parallel serial output? Here we are taking at rightmost multiplexer, that also at this number 2. Okay. Number 2 means select 1, S1 equal to 1, S0 equal to 0 at that. Okay. Right. Now we'll see the working. It will work in 4 states. Okay, one is hold state, another one is right shift, another one is left shift, and the last one is parallel in, parallel out. Suppose whenever this select 1 equal to 0 and select 0 also 0, it will become hold. When S1 equal to 0 and S0 equal to 1, it is doing right shift, nothing but serial in, serial out. When S1 equal to 1, S0 equal to 0, it is doing left shift, serial in, serial out. When both are 1s, it is doing parallel in, parallel out. How this doing? I will show with different diagrams. Okay, this is for hold, this is for right shift, this is for left shift, this is for parallel in, parallel out. Okay, we'll see one by one. Okay, first we'll see about hold. Why we calling hold? Now I applied my selects, both selects are 0 0. So selects are 0 0 means binary 0 0 means it will become decimal 0. So this decimal 0 data input of multiplexer will become selected, that will go to the output. That output is going to data flip-flop D flip-flop. So it will produce same output, and that is again feedbacking to the same 0. So it will become hold. We are getting same state as previous state, na? Now also we are getting previous one. Okay. Of course, this is going this side, but this is going this side. But see here, we have not applied any parallel input, so that we cannot say we are taking parallel output. When we apply parallel input, that time we can say. So even though it is going, that is not considered. So this red line loop only will be considered. Here also happening, here also. You can see the direction also. It is going upward and coming downward. Okay. So this is about hold. And this connection going like this also. Suppose this is coming down and going here and going here. But here even it go to here, when select 0 0, this decimal 1 cannot be selected, na? So this is also not considered. And we don't have any use with this hold condition, but this connection is required for other states. Okay, there are some right shift, left shift is there, na? For those it required. Okay, we'll see. Now we'll see what happening when I apply select 1 equal to 0 and select 0 equal to 1. Okay, I told right shift happening, serial in, serial out. So here this 0 1 means decimal value 1. This one of this multiplexer, it will be selected. This number 1 will be selected. So here I am giving my serial input bit by bit here. That bits come here and go to this and come out here. Okay, even though they come out here, it won't be considered. We are not giving any parallel in. So it will come down. You can see the direction. This will go in this way also, but when select is 0 1, it won't be selected. It is also not considered. So it is, there is another path. It is going like this, again like this coming, like this, like this, like this. Finally we are getting output at here, at this D flip-flop. We will get serial output here. This is serial out. Okay, we given serial in here, we get serial out here. Okay, now we'll see what happening when I apply S1 equal to 1 and S0 equal to 0. In this case, here I am giving input. Previously I given input here at the left side, so it is right shift. Now I am giving input at the right side, it will become left shift. So here I am giving input. Now 10 means decimal value 2. So this select input 2 will be selected. I am giving serial input here. It will go like this. Even it is come out, it is not considered. We are not giving any parallel. So it will come down. And here this path also there, but whenever select is 10, it won't be considered. It won't be selected, na? So it is coming down in this path and going here like this, again like coming like this, again coming like this, and here we will get serial out. This is serial out. Okay. Now finally last one, parallel in, parallel out. How happening, we'll see. See here I am giving parallel in here, 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 here. We are giving to all flip-flops at a time, because 1 1 binary means decimal 3. So that it will be selected, 3 will be selected, is going coming out, and it is going and coming out, it is going and coming out, it is going and coming out. So we are applying parallel input and we are taking parallel output here. Okay, right.